Okay, guys. So let's pick up where we left off last time. We covered some issues related to things you need to know with statistics if you're going to try to do a statistical study. So let's just see if you remember a few of these terms. If I wanted to collect data from everybody in the city of Terrell, I would be collecting data from which? A statistic or a population? A sample or a population? A population. But instead, if I just took a small group from Terrell and that was in my data collection, that would be a sample. If I were to ask you to tell me what level of measurement this is, let's review quickly. What's my lowest level of measurement? When basically I just don't know anything other than the name. Nominal. If I can do a little bit more with it, like maybe I can, remember what the next level is? I can put it in order. That would be ordinal. If I can do a little bit more with it than that, like I can actually, it's got numbers involved and I can get meaningful differences, that's interval. And the highest level is what? Ratio. Ratio. Okay, so see if you can answer this. What if I have something where I've collected data measuring the temperature of, say, the crisper drawer inside a refrigerator at different time periods during the day? What would that be? Okay, I'm hearing not a lot of feedback, but I have heard somebody say ordinal and I heard somebody say interval. So if I'm getting something like temperatures, and maybe it's 41 degrees, and the next time it's 39 degrees, and the next time it's 40.5 degrees. They don't all have to be the same, but they're probably going to be pretty close to each other. So my question is it more than nominal? Yes. Definitely. Ordinal just means I can put them in order, but I don't get any meaningful differences. If one of them's 41 degrees and one of them's 39 degrees, can I figure out the difference between those two? Yes. I sure can. So does that mean it ought to be something higher than ordinal? Yeah. Now, would it be interval? Because the difference between ordinal and interval is I can calculate a meaningful difference. I have to have numbers involved, right? So I can get a meaningful difference from 41 degrees to 39 degrees is a difference of how many? 2 degrees. But the question is, can I go to the highest level and say it's ratio? Why not? What has to be true for it to be ratio? Okay, 0 is an absolute, can't go lower than that. As in temperature, 0 is just a point on the scale. Yes, question? That's correct. Well, 0 is just a point on the scale. I mean, just like if I said it's 10 degrees, that's a certain temperature. 0 degrees is a certain temperature. It doesn't mean the absence of temperature. As, if I can say it's twice as much as something, that would be ratio, because I'm able to make that comparison based on the fact that there is a 0 starting point. Okay, so good question, because it takes a little bit to kind of get all these straight. Okay, so that's a very quick review of what we talked about last time. Now let's try to start putting some pieces together if we were going to design a statistical study. So if I gave you an assignment, and don't panic, I haven't done this, and I'm not planning to, but if I said, I want you to conduct some sort of study, wouldn't you need to decide what it is you want to study and who you need to collect data from? I mean, that sounds like a reasonable starting point, okay? Then I'd have to come up with some sort of plan on how I'm going to collect my data. And if I decided I was using a sample, wouldn't I have to figure out how I'm going to form my sample to be sure that it's representative of the whole population? Would that be important? Okay, let me give you a quick example I want you to think about. Let's say, anybody been to Town East Mall recently? Y'all ever go there to shop? If you're like me, it's just so easy to shop online. I don't go places very often. But let's just say you are going to conduct some sort of survey at Town East Mall. And maybe the question you wanted to ask people is, what is your favorite store to shop at in the mall? Well, think about it for a minute. If what you do is stand at the entrance to Abercrombie, and you are only asking people as they walk into Abercrombie, what's your favorite store to shop at? Do you think your design for how you're collecting your data might give you a sample that's not very representative of the mall as a whole? Yeah, so there are things you have to think about when you start to design a study to be sure you're going to get good information. Now, you need to collect the data. So whatever question I'm asking, I'm going to have to record answers, or if I'm observing something, I'm going to have to write it. I have to have some way of collecting it. Then I'm going to use descriptive techniques to describe the data. My whole purpose in doing this probably is so I can interpret the data and make some sort of decision, whether it's, yes, this is successful, or no, it's not. And then I need to be aware if there's something in the process that might have caused some errors. So we're going to look at several scenarios and see if we can figure out the things we need to be careful about. All right, first one, as far as data collection, is called an observational study. So a researcher observes and measures characteristics of interest of part of a population. Now, if you're doing that, then you might, here's an example of something a researcher might record. They are looking at children maybe in a daycare setting, and they want to record the mouthing behavior on non-food objects of children up to 3 years old. Okay, that is sort of a weird sounding thing to observe. Any of you guys either do some babysitting or you have younger siblings at home? What do little bitty kids want to do all the time? No matter what you hand them, where does it go? It goes in their mouth. They put everything in their mouth. I mean, I can remember the first time my oldest child picked up a cricket, a dead cricket, and stuck it in his mouth. I was so freaked out. But that's just what kids do. They put things in their mouth. So that's the observational study. They're just watching to see, and they're going to record what these kids do. Okay. Hang on a second. I think I missed one, didn't I? No. Okay. Now, an experiment simply means that you are going to do something where you're applying a treatment to a certain part of a population, not everybody, just part of it, and you're going to observe responses. So here's an example. It says an experiment was performed in which diabetics took cinnamon extract daily while a control group took none. After 40 days, the diabetics who had the cinnamon reduced their risk of heart disease, but the control group experienced no change. This was an actual experiment that was done. Now, do you think it was important that there was what's called a control group? Yes. Yeah, because what happens if you just give somebody some quote-unquote medicine and you don't have anything to compare it to with people who didn't get it? Have you ever heard of something called the placebo effect? Yes. What does that mean? Exactly. In fact, have you ever maybe seen this with little kids where they say, you know, oh, mommy, I have a headache, or my throat hurts, because they like the medicine. Maybe they want aspirin or something. And so mommy starts giving them sweet tarts and calling it an aspirin. And of course, they feel better as soon as they get one. All right. The placebo effect is simply psychologically, if you think you're getting some medicine, a lot of times you convince yourself you feel better. So you have to have something to tell. Are people having good results because they just expected to get better, or is the medicine itself actually making a difference? Now, we've covered observational study. I don't do anything to change. I just watch and record what I see. We've talked about experiment. That's where I'm going to apply some sort of treatment, and I'm going to record the difference between those who get the treatment and those who don't. Here's a third type of data collection. You can have something that's a simulation. All right, now notice carefully what the definition is for a simulation. It uses a mathematical or physical model to reproduce the conditions of a situation or a process. And it will often involve the use of computers. All right, now think carefully. I bet you guys use simulations pretty often. Do I have any gamers in here? Ah, have you ever considered what's involved with the way those games are designed? It's a simulation. I mean, it's programmed so that if your player does something, then something else is going to happen. So it's simulating in real life what could happen. What are some other things in the real world that use simulations? Can you think of an example? Huh? Have you ever thought about, think about weather forecasts, okay? How do you think they come up with weather how do they know who to tell that they're under a tornado warning? What do? Well, they look, but they have to have something that's going to predict where this goes. They have everything's based on computer models. They have programs that will simulate these conditions. You put in all the variables and it will tell you what they think this thing will do. Now here's another example. Automobile manufacturers use simulations with dummies to study the effects of crashes on humans. Is that a good thing? Do you want to volunteer to be the guy that gets strapped in the car and crashed into the wall at 60 miles an hour so they can tell what happens to you? What if it's 60? Yeah, so things that aren't, things that aren't very safe, you would want to have a simulation so you can tell. And they have the ability to determine how would this affect a real human if this happened in the real world. So let's look at the fourth one, called a survey. You're going to investigate one or more characteristics of a population. There's a lot of different ways you can do a survey. Oftentimes, you can interview people, kind of like if you go to the mall and you just stand there with your clipboard and you start talking to people. You can do it by mail. You ever get those in the mail? No. You will. Just wait till you're over 18. You'll have things that come in the mail. Telephone. You ever get the junk calls where they say, excuse me, can you answer just a few questions for me? Okay, yeah. Those are common ways that surveys are done. We're getting smarter about, back in the old days before caller ID and before cell phones and everything, when you had a phone call, you had no idea who it was, and it was a lot easier to get people to respond. Now it's a lot harder to get people to respond, because when you see it's somebody you don't know, do you typically answer it or not? Yeah, and you can get on a do not call list. So here's an example of a survey. Okay, a survey is conducted on a sample of female physicians to determine whether the primary reason for their career choice is financial stability. In other words, do you become a doctor because you want to make a lot of money? Now, let's look at some methods of data collection and see if you can identify, out of these four we covered, which one you think would be the best way to collect data. All right, what about if you wanted to study the effect of changing flight patterns on the number of airplane accidents? Okay, I heard at least one person say simulation. Remember, simulation is where you can do a computer model to tell what's going to happen. Would it make sense to just do an observational study? Do you want to change the flight patterns and sit and watch to see how many crashes occur? Let's hope not. That would not be a good plan, okay? You could do, some other things, but by far simulation would be the smartest way to do it, okay? It's impractical and probably not very safe to actually create the situation in real life. All right, look at this one. What if you wanted to do a study to determine the effect of eating oatmeal on lowering blood pressure? Okay, I hear one vote for an experiment. Do y'all agree with that? Okay, why would you want it to be an experiment instead of an observational study?
Because they might not be the
Well, what would you have to do if it's going to be an experiment?
You have to measure the effect. You have to have a control group.
There you go. This is where you need a control group. You would need to have a group of people who had similar blood pressure issues. Hey, similar blood pressure issues at the beginning. And a certain number of them would eat oatmeal. And then you would have some that they're going to eat something else. Maybe you're telling them, you know, I want you to eat whatever you would normally eat for breakfast. Just don't eat oatmeal every day and see what happens. Okay? So that's an experiment. That way you could tell what difference oatmeal makes. How about this one? A study of how 4th grade students solve a puzzle. So you guys think observational method of data collection makes the most sense here?
Yeah.
Why would you not want it to be something like an experiment?
They all do it differently.
Yeah, if you had an experiment, you'd have to tell one group how to do it, and then you'd watch and see what others did. If I just want to know how would most 4th graders approach solving this puzzle, then definitely observational study makes the most sense. I don't interfere with it. I just record what I see. Okay. A study of U.S. residents' approval rating of the U.S. president. How would you go about it? That's a what?
Survey.
Yes, the survey has it. So you could either do it by phone, mail, email, and you would just collect that. Now, have we covered how you would choose a sample if you're going to have a sample? Would you have we covered how you would choose a sample if you just wanted to survey a sample? Not yet. We haven't talked about that. But on a case like this, how easy would it be to ask everybody in the U.S. what their opinion is of the president, if he's doing a good job or not? Probably not very easy. So here are some things that we want to look at, and we will get to how you might construct samples and such in a little bit. But let's talk about some elements of experimental design. The first one is control. Now, you've got to control for effects other than the one being measured, because sometimes you may have something that's called a confounding variable. Now, what does it mean when you hear the term confounding? Yeah, you're confused about something. There's something that's kind of giving you mixed signals. So that happens if an experimenter can't tell the difference between the effect of different factors on some variable. In other words, more than one thing might be bringing about the change. Here's an example that could be a confounding variable. A coffee shop owner remodels her shop at the same time that a nearby mall has its grand opening. So if business at the coffee shop increases, do you think it's because she did the remodel, or is it because the mall has just opened and there's a lot more traffic in the area? Would that be hard to tell? Might be both, but that's why there is a confounding variable there. There's more than one thing that might present it. Now, we hit on the placebo effect a little bit ago. That occurs if a patient reacts favorably to a placebo, and that just means that it's what? Yeah, it's like you've heard of sugar pills, okay? Kind of like the idea of giving a sweet tart instead of giving a baby aspirin. It's not medicine at all, but it makes you think that you're getting some sort of treatment. Now, in order to make sure that you don't accidentally introduce some bias, you may want to have a blind test. Now, here's what that means. You're not going to tell the person who's getting the medicine whether they got the real thing or the placebo. Now, would it make sense to tell them in advance? No. So anytime that you're going to have some sort of control group, it's definitely going to be a blind test, because the subject, you've got to agree that it's okay with you to either get the real thing or to get the placebo if you're going to participate in this group. Okay, because they're going to ask you before you sign on, are you willing to go either way on this? Okay? Now, do you think there's the potential that not only if the subject knows if they're getting the real thing or not, that there could be a problem if, say, the doctor knows whether you're getting the real thing or not? Could they maybe accidentally tip you off as to which group you're in? Let me give you an example of what happened to my niece and her husband. When they had their first baby, they sort of had a contest going with each other. And they had a sonogram, but they both said, we don't want to know what the sex is. And so they had the sonographer put in an envelope, seal it up, whether it was a boy or a girl, and gave it back to them all sealed up. So their contest was to see who could hold out the longest. You know, they had it on the fridge with a magnet, trying to see who could go the longest. They got all the way to like week 39. Those of you who know anything about babies, week 40 is when you're full term. Normally you have a baby. And they were having a number of sonograms done. She was part of some study. I don't know. And so they kept going back, having the same guy who was doing the sonogram. And so the very last sonogram she had, this guy, he knew they didn't want to know. And he said, well, I've really enjoyed getting to know y'all and working with you. Maybe next time it'll be a girl. Yeah. Let the cat out. And then he tried to backpedal and say, well, not that this one's not a girl, you know. Yeah, well, they already knew. So a double-blind experiment would be if the person who is doing the experiment, the person who's doing sonograms, or the doctor, or whoever, doesn't know if you're actually getting the treatment or if you're in the control group. And that way you don't accidentally slip up. Okay, questions so far? We good? Okay, here's something else that's important in experimental design. Randomization. All right, I bet you guys can easily tell me, what does it mean if something is random?
Random.
There's no pattern to it. There's not anything logical to predict it. Okay, so it's just the process of putting people into different treatment groups. So in other words, let's think about this. Let's say you were going to sign up that you were willing to be in a study for a new drug to treat acne. Okay, it's not life and death, but it's still probably something that matters to you. Now, if they get a group of 100 people who said, yeah, I'll participate in the study, and if they go through and they hand pick, well, let's pick the ones who have the worst cases, and we'll put them in the control group, and we'll take the ones where their acne is not that bad, and we'll give them the treatment. Would that give us valid results? No, there has to be some way of randomly assigning which group you go into. If it's completely randomized, then that means you probably have some kind of process. Like, have you guys ever used the random number generator in the calculators? Did you know you can do that? Like if you wanted to randomly generate numbers between 1 and 40, you can put that in the calculator, and every time you hit enter, you get a different number, and it's completely random. There's no pattern to it, okay? So you could do something like that, give everybody a number, and then based on that random generation, they're either going in the control group or into the treatment group. Here's another way you could randomize it. It's called randomized block design. So in other words, you're going to divide people into blocks or groups where they have something in common. And then within each block, you randomly assign subjects to treatment groups. Okay, so if we were going to maybe, let's say we have the not very bad acne cases and the really bad acne cases, we might want to divide them out that way first, and then within those groups, make sure we get some of each in both the treatment and the control group. Okay, so look at this one. An experimenter testing the effects of a new weight loss drink may first divide subjects into age categories, and then within each age group, randomly assign subjects to either the treatment group or the control group. Now, you guys are still in high school. You do not have this problem yet, but do you think age impacts how easy it is for you to lose weight? Absolutely. Just wait till you turn 40. and try to go on a diet, and it gets really tough to be able to see any big change in your weight. So that's why that might make a difference. Younger people have a faster metabolism. So if you were to divide everybody up by age group, and then you divide out who's going into the treatment group and who's going into the control group, you might get better results. Here's another one that's kind of cool. It's called the matched pairs design. Subjects are paired up according to a similarity, and then one of the pair would go into the treatment group while the other one goes in the control group. We have some twins here, right? Are you guys identical twins? Uh-huh. Yes? Okay. Do you realize that you are a researcher's dream for a number of things? Think about it. Think about it. What's true about their DNA? It's this. Yeah, I mean, they are as closely matched as you can possibly get. So if they wanted, if whatever somebody is researching, if they have identical twins and you put one in a control group and one in the treatment group, you get awesome data to see how effective it is. Okay, so yes, that might become a sideline hobby you can do to get yourself through college. All right, just don't volunteer for any really dangerous stuff. Replication. Okay, that is the repetition of an experiment using a large group of subjects. All right, guys. Anybody in here gotten the flu this year? Really? Everybody has avoided the flu? That is awesome, because I'm sure you've all heard it is horrible this year. Huh? Is that what it is? That's why the ones who aren't here aren't here. Okay, so that, yes. So do y'all have very much flu at Terrell High School right now? Okay, so in general, yes. Now, so let's say they wanted to test a vaccine against a certain strain of influenza. So 10,000 people get the vaccine and another 10,000 are given a placebo. Because of the sample size, was it replicated a large number of times? If you have 10,000 that get it and 10,000 that don't? As opposed to if you only gave it to 100 and then you watched 100 who didn't get it, the more times you repeat it, the more valid your results would be, right? Okay, so, which by the way, anybody in here get flu shots this year? How a few of you. But exactly, how do they come up with what they think needs to go in the flu shot? They do some research. Clearly, sometimes they don't hit the nail on the head, because why are they saying this year's vaccine is so ineffective? It's the wrong strain. They were guessing what.
It mutated again.
Yes.
So they don't have a vaccine yet for this strain.
Yes. So I mean, it's just they're guessing when they start giving out flu shots what they think will be the most prevalent strain, and they missed it by a long shot this year. And that's why it's been so bad for so many people. It's a really tough strain anyway, and it wasn't one of the ones included in the vaccine. All right, so look at this. A company wants to test the effectiveness of a new gum developed to help people quit smoking. So see if you can tell me a potential problem you might see if this is the way it's designed, and then suggest how you would improve it. The company identifies 1,000 adults who are heavy smokers. The subjects are divided into blocks according to gender, and females are given the new gum, males are given the placebo. After 2 months, the female group has a significant number of subjects who quit smoking. Do you have valid data?
No.
Why not?
Like, you didn't further, you didn't go on and split them into 2 different groups within groups.
Okay, so if I'm hearing Natasha right, see if you guys would agree with this. I think what she's saying is after you split it into males and females, you should have divided those groups into control and treatment groups so that you had some of each in your experiments. Like, it wouldn't be just females that got the gum, but you would have some females, some males, and then some females and some males who didn't get the gum. Is that what you're saying? Okay. And do you agree with that? Absolutely. What's the potential problem with doing it this way? Okay, when you say bias, tell me what you mean by that.
My females might have different factors into play.
Very good. There may be something that's inherent to females that makes them either more likely or less likely to be successful with the gum, but you're not going to identify that by conducting it this way. So here's the issue. The groups you divided them in are not similar. You could have a different effect on men than on women. So exactly what Natasha suggested, if you divide them first into blocks, males and females, and then within each block randomly assign them to a group, you would get much better results. All right, so far so good? Here we go. Simple random sampling. If you guys came in here and I were to tell you we are doing something different today because I have assigned a number to each one of you. If you look on your desk, you've got a number there. And I have every one of those numbers up here in some little bowl. And I said, I'm going to draw a number. And if I draw your number, you have an A for the semester. You pick up your stuff, walk out. You don't have to come back.
I'll go first.
Okay. Would you agree that everybody has an equal chance of being selected?
Yeah.
As long as everybody's number is in there one time and I pull out one number, everybody has an equal chance of being selected. And that's necessary for this to be a simple random sample. All right, so that would be an example of one. And so each sample of same size has an equal chance of being selected. So instead, if we divided maybe into groups and I were going to choose one group, I would still have to have those groups be the same size, and each one of the groups would need to be equal opportunity to be selected. Okay, so here's another one, and this is really kind of a weird scenario. Let's say you're a vet, and you need to check for ticks on a farm that has 250 sheep. First of all, I think I'd say, let me think about doing something else, but I'm going on a tick hunt. How in the world am I going to figure out if there is a tick problem in this herd of 250 sheep or not? What would be one way we could figure it out? Okay, she says we could treat all of them anyway. That might be too expensive though. Maybe it costs more to treat for ticks than it's worth, and so I need to know if I really have a problem. Well, that's it. Okay, back up, back up, back up. The question is, I'm trying to determine if I have a pervasive problem with ticks on the sheep. So do you want to check all 250 sheep? What do you think? Do you want to check all? No. I'm not going to be paid per sheep. I just need to be able to determine if there's a problem. Would it make sense to get a sample? I think so. Now, how would you get a sample? Okay, say that one more time. We can do what? There you go. If I wanted to number the sheep, let's say they've all been branded or something, and so they already have numbers somehow that
They get ear tags.
Oh, ear tags. Thank you. Okay, yeah, you can tell I was not an ag person. So if they've got ear tags, I could look for the numbers. Maybe I randomly select some numbers and I go hunt them down. As opposed to, here's a question. Let's say I'm standing on the hill and I'm looking down in the valley where most of the sheep are, and there's a cluster of them that are drinking water out of a nasty little pond underneath some overgrown stuff. And I say, well, let me just go check those guys. Is that going to be a representative sample of the herd as a whole? Probably not. I mean, first of all, this is one little group that's clustered together in the same environment. I need to have some way of checking something that's more broad. So here's their suggestion. Number the sheep, mix up numbers, maybe draw 15 randomly, find those sheep and see if they have ticks. Now, I told you your calculator will do a random number generator. There's also tables that are created, and this is pretty old school. I'll just show you how it works. If you wanted to pick some random spot on this table, and let's say that we had, this is our sheep problem. There are 250 sheep. So the only numbers we would be interested in would be between 1 and 250, right? Okay, so I just close my eyes, pick a spot on this table, and if I'm going to start right here, since I've got 250 sheep, I'm going to look at 3-digit numbers. What are the first 3 digits? 719. Okay, is that bigger than 250? Yeah, so I'm going to throw out 719. Next 3 numbers, 662, that's too big. 738, that's too big. 650, that's too big. But look where we are now. Okay, here was 650. The next 3 digits are 004. I'm on a hunt now to find sheep number 4, then sheep number 53. That one's too big, that one's too big. 129, and I would do that until I came up with 15 numbers. That's one way I could get random numbers. Make sense? Okay. So here's another way that we could devise a sample. Remember, we're trying to come up with ways that we can get a good sample. So that was our simple random sample. Let's talk about a stratified sample. Okay. Do you know what a strata is? It's just another word for a group. Okay. So if you divide a population into groups or a strata and select a random sample from each group. So it's kind of the idea where we talked about the block. You can put them in groups according to something that they might have in common. For example, I wish I could get that to go away. I don't know why it popped up. But let's say you were going to be looking at something related to folks who live in a particular county, and you want to make sure that you aren't skewing your data because you're only going to the wealthy side of town, or you're only going to the low income side of town. So instead, maybe you divide households according to their income. So you get low income, medium income, high income, and then you can randomly select households from each of those. That would be a stratified sample. Make sense? Oops. That's not what I wanted to do. Sorry. Let's go back here. Okay. There we go. Now, here's a different scenario. You could get a cluster sample. The difference here is after you divide everything into groups, your population into groups, you're going to pick all the members in one group, but not all of the groups or the clusters. So for example, I could divide that county up by zip codes, and maybe I'm just going to survey everybody that lives in the same zip code. Okay, now that may not give me good data. There might be some reason that it's good to devise it that way, but then again, there may not. So you got to pay attention to that. The systematic sample, you guys ever, you ever been to like a playoff game for professional team? Like, yeah, either the Rangers, the Mavericks. I know one year when the Mavericks were doing really well, I guess it's back that, was it 2009, they won the NBA Finals, whatever. Maybe, no, it might have been later than that. But anyway, my son, who's a basketball coach, really wanted to go get tickets for a playoff game. So have you ever been through the process on how you do that?
Hard.
It is hard. It's sort of like a lottery. There's a lot of it that's just a systematic sample, because we showed up, American Airlines Center, and they had somebody handing out numbers. And so everybody's lined up, you get your number, you would walk around the building, and if you were able to get back and get another number, you could do that as many times as you were able until they called time and they were going to then select numbers for being able to buy tickets. All right, that's a systematic sample. You can choose a starting value at random. So they would just randomly pick some starting point, and then you're going to choose every so many of the population. Sometimes you might pick every 5th one. They might say, we're going to start at this number and we'll take everyone from that number forward. You get to choose, but that's the way that it's designed. There's a system to it. So, for example, back in West Ridge County, you could assign a different number to each household. Randomly choose a starting number and then select every 100th household. All right, see if you can answer this. You're doing a study to determine the opinion of students at your school regarding stem cell research. See if you can tell me what kind of sampling technique is used here. All right, if you divide the student population with respect to majors, and then you randomly selecting questions, some students, within each major, what have you used for your sampling technique? What do you think that is? Okay, I hear stratified. Tell me why you would think that's stratified. So you have divided into groups according to your majors, and then you're questioning some students from each group. Are we in agreement? That sounds like stratified. Let's see if you're right. You are. Very good. All right, how about this one? You assign each student a number, you generate random numbers, and then you question each student whose number is randomly selected. That's just simple random, right? You've got random numbers, and if I happen to pull your number, you're going to be the one I go to. And we have reached the end of section 1.3. Okay.